Hi, welcome to my video on finding the area of a triangle. I'm doing a review of the area of a triangle using, I'll show you a formula that I did when I did the unit on sine law and cosine law, etc. So I'm doing this now as a review because we need it when we're going to find the area of a sector or the area of a segment of a circle. So for this video, all my units are going to be centimeters. Let's find the area. Notice we have a triangle, 5, 5, and 6 isosceles. This is the apex angle. So if I drop a perpendicular from this angle down to the base and make it, that's an altitude, then because these two sides are equal, I form two congruent triangles because this angle and this angle are equal, and this is the right angle, so the triangles are congruent by HL, hypotenuse leg. That means because the triangles are congruent, the altitude from the apex angle splits the base at 3 and 3. So that means that we can find the height using Pythagorean. So c squared is a squared plus b squared. C is the hypotenuse, which is 5. And A is 3, and B is H, the height. So 25, 9, H squared. So H squared is 25 minus 9. So H squared is 16. So H is plus or minus the root of 16. So H is plus or minus 4. So we'll say the height is 4 because we can't have a negative. So the area of a triangle is a half the base times the height. So the base of the triangle is 6, and the height is, we just found it to be 4. So a half of 6 is 3, so 3 times 4 is 12. And the units are centimeters, so square centimeters. And sometimes in the trig, working out, we can find the area in radical form when we have this sort of a triangle. Notice we have a right triangle with a 30-degree angle, so that makes that a 60-degree angle. So what happens, one of the special right triangles is the 30, 60, 90, and opposite the 30 is n, opposite the 90 is 2n, and opposite the 60 is n root 3. So that means, according to this, that 2n is 8. So divide by 2, n is 4. So opposite the 30 is 4, and opposite the 60 is n root 3, so it's a 4 root 3. So we have the base and the height, because in a right triangle, the perpendiculars are the base and the height. So the area is a half the base times the height, and the base is 4, and the height is 4 root 3. And that gives a half of 4 is 2. 2 times 4 root 3 is 8 root 3. And again, it's centimeters squared because it's area and is in simplest radical form. Another one I want to go over is this one, but I'm going to do this one. The easier way to do this is, the easier method to do this is the area is a half of AB sine of theta. Theta is the included angle. In other words, if you have a triangle with two sides and an included angle, then you can find the area. So it's a half of 10 times 12 sine 48. And you plug that into your calculator, and when you do, you'll come up with 4.58, and you want to round it to the nearest tenth, so that's approximately 4.6, and it's centimeters squared. So that's if you have two sides of a triangle and an included angle. You can work use this formula because we practiced this formula when we did the sine law and the cosine law. Actually, the sine law is derived from this formula. But another way to do it also would be to drop the perpendicular down to the base and call it a height. So, SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. That's an H there for hypotenuse. So based on that because we have a 48-degree angle, this is the opposite side, and this is the hypotenuse. Now this is the height. Don't get this height mixed up with this H. So we have opposite and hypotenuse. So the sine of 48 degrees is opposite, which is the H over the hypotenuse, which is the 10. So cross multiply, H is equal to 10 sine 48. And if you use your calculator, that comes out to be 7.43. Now that we have the height, we can go with the formula area is a half base times height. So the base is 12 and the height is 7.43, and multiply that out and we'll get again 4.58, and so it's approximately 44.6. And it's so you could do it this way if you remember the formula: two sides and included angle works out fast, or you can drop the altitude and do a little bit more work, giving you different options to find the area of a triangle. Okay, now we have another question. It says that the arc AEB is 278 degrees. O is the center of the circle. The diameter is 9. Find the area of the triangle AOB to the nearest tenth. Again, we have a triangle. Let's see. We have a diameter. Let's see what we have. We have a diameter is 9. So twice the radius is the diameter. So that means the radius is a half of that, which is 4.5. So we got a 4.5 and a 4.5. And again, the units are in centimeters. So notice now we have two sides. We need this included angle. So if this arc ACB is 278, what is the arc AB? So the arc AEB plus AB is 360. So the arc AEB is 278. So AB is 360 minus the 278. So AB comes out to be, and that works out to be 82 degrees. So if this arc is 82, the central angle is the same size as the arc that it cuts off. So this angle O is 82 degrees because the central angle is the same size as the arc. So that means we have a triangle made up of two sides and an included angle. So the triangle is a half of AB sine theta, the included angle. So that's a half of 4.5 times 4.5 sine of 82 degrees. And when you work that out, you get a 10.026 if you use your calculator. And to the nearest tenth is, tenth is there, that's, so it's 10 centimeters squared. Because tenths is here, this is less than 5, so you can't add on to the zeros, so just 10. And another way also, when you're dealing with this triangle, two sides and included angle, like this. But when you're dealing with a circle, a center O, that's a radius and a radius. So if you got a circle that's doing this with this center, so some books say you have an r times an r sine theta. So you have a half r squared sine theta. So I use half of AB sine theta because it makes no difference if it's a circle or not. It's the product of these two. But because it's a circle, we have an r being squared. So if you take the 4.5 and square it, that's the same as taking 4.5 and multiplying by 4.5. So if you see this, because it's a circle, you might see a half of r squared sine theta. Yeah, but I go back to basics, and it's a half of AB sine theta, the two sides in the included angle. Number 5, this AB is tangent at T. AB is tangent at T. AB is tangent at T, touching the circle at one point. O is the center of the circle. The the angle PTB is 57. The angle PTB, so this angle right here is 57 degrees. The area of the circle is 18 pi square centimeters. Okay. Find the area of the triangle PTH to the nearest tenth. So we got to get the area of the triangle. And again, we're working on half the base times the height, or a half of AB sine theta, etc., etc. So what do we have? We got a tangent, and tangent, that's the diameter right there, going on through the center. So the angle subtended by the diameter, so first thing I see is that this angle right here, PTH, is 90 degrees. Another way to think about it, this is 180 here. This arc is 180. So this is an inscribed angle. PTH is an inscribed angle. So the inscribed angle is half the arc. Since that's 180, this angle is 90. Or remember that this is a diameter. This is an inscribed angle subtended by the diameter. So this diameter is 180, so this angle is 90. Okay, continue, and we have, this is the tangent and a chord. So the angle formed by the tangent and the chord, this angle is also equal to this one here, which is the inscribed angle subtended by this chord, or cutting off this arc. So these are equal. So this angle is 57. And that leads us to this one if I wanted it. So this would be 90. These two add up to 90. So this is a 33. 57 and 33 adds up to 90. But we want the area of the triangle. We don't have any sides, but I have the area. So the area of the circle is 18 pi. The area of the circle is pi r squared. So that means that pi r squared is equal to 18 pi. The pi's cancel, so r squared is equal to 18. R is equal to plus or minus the square root of 18. R is equal to plus or minus, that's 9 times 2. So that's plus or minus 3 root 2. So R is 3 root 2, which is the square root of 18. So, but I need, this is the diameter. So the diameter is twice the radius. So the diameter is twice 3 times root 2. So the diameter is, 2 times 3, I'm going to say 4. 2 times 3 is 6 root 2. So the diameter is HP. So HP is 6 root 2. So this is 6 root 2 from here right to there. Okay, now we need another side. So I have a 57 degrees is 37. I need one more side. So I can either find this side to go with two sides and this included angle, or I can get this side and have this side and this side with this included angle. So whatever side you want to get. Or you can go and use your trig and get both of these sides here, which is the perpendicular. Use the trig to get both of these and use half the base times the height. But let's go with 57. So SOHCAHTOA, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Make that an H. And tan is opposite over adjacent. So I'm going to redraw this triangle just quickly. There it is. So that's H, T, and P. And this is 6 root 2. This is a 57. This is the 90. So I'm going to use, I want to find this side right here. So if this is adjacent, that's opposite, that's hypotenuse. So I'm going to use cosine of 57 degrees. Cosine is adjacent, which is HT over 6 root 2. Cross multiply. HT is equal to 6 root 2 cosine 57. And so when you work that out, you get on your calculator, you get 4.621 dot dot dot. Use your calculator, and you can round that to the nearest tenth if you want. Some people don't round it yet, they wait. Now I have two sides, so we put 4.6 right here. So the area is a half of AB sine theta, the included angle. So it's a half of, and again, you can take the 6 root 2, one side, the other side is 4.6, and the angle we dealt with was the 57 degrees. Plug all that in your calculator, and you come up with 16.3, and then you round that off to the nearest tenth, 16.4, and it's in centimeters, so it's square centimeters. So a good little problem to do, in that you're doing a lot of little skills. The tangent chord property with this angle here formed by the tangent of the chord is equal to this inscribed angle here. And you got a tangent meeting at a point, and you got this angle here is 90 degrees because it's inside the semicircle, subtended by the diameter. So, and you got the area of the triangle, you got the trig being used to get the length of the side, and you had to know your formula to get the area of a triangle. Half of AB sine theta. A lot of math in there. A lot of excellent problem. So that brings us to the end of this video. And again, if you like the video, click the like button, click the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing the video. Hope the video helped you. Bye-bye.